Hello, hello, good morning. How are you all doing today? I hope that you can hear me. Apparently things aren't working too well on my internet side, which is a little bit sad. Let's see, Twitch is saying my bitrate is really low. It's not restream because my OBS is dropping 65.2% of all frames that I'm trying to send out, which is not great. It's also sending out my kilobits per second is going all over the place. Every once in a while I might be able to get up to 3,000 and then it drops down to like 1,200 or so. I'm a little bit worried that either you can't hear me or it's just going to be really choppy. Let me see if I could put a preview up and listen in here. All right, how does this sound? Can you actually hear me? Okay, yeah, I am so delayed now, which is not that surprising. But yeah, YouTube is not receiving enough video to maintain smooth streaming. Yeah, it's not great. And it doesn't look like it's clearing up because this started right when I first started, and it's continuing to go. So unless it clears up within the first few, I don't know, 10-15 minutes, we might have to cancel the stream and work on this later because I don't think this is gonna be watchable. Stream preview shut off on my Twitch. That's not great. All right, well, we can I've got the recording going on. That should be fine. Let me double check it's not something like me running out of disk space. No, okay, so I still have 189 gigabytes of space. That's where my recording is going. So it's not me, it's not like the recording of the video is causing the issue. Maybe I'm trying to record at too high quality. This worked last time. I don't think I've changed the settings since last week. So that's a little bit unfortunate. I guess what I could do is I'll try stopping the recording and we'll see if that clears it up. Still dropping frames like crazy though. Nathan, hello, how are you doing today? You never played this game? This game is a fun game. It's a programming game. Where you solve electrical engineering problems. For the solutions. You'd like to visit Shenzhen someday? Yeah, I've never been to China myself. It would be interesting to go and visit some of the Asian countries because I've never been to any of them. All right, well, you know what the other thing I can do? See, what can I do while I'm streaming? I'm gonna drop my bitrate down that I'm attempting to send out down to, I think 3,000 is the lowest I can go before it starts getting bad. me start the recording again. And this might, it's still, it might be better. We'll see. It might be recovering. I'm seeing above 2,500 for the kilobits per second now. But okay, so this specific puzzle, we are making a aquaponics chip for somebody. We have this Wi-Fi that's going to give us a series of numbers all in one tick, like at one time. And we have to control this motorized arm here to go and do various stuff. So if they're gonna send us 222, what that means is oh, I think that's in the here in the manual. I have to figure out. Oh, it's okay. Destination station, tool clean time, tool feed time. So 222 means go to station 2. So 012. So go to this station, activate the tool cleaning for 2 seconds. And I mean, I don't know if it's seconds, like 2 units of time, and then activate the tool feed for 2 milliseconds time, and not at the same time. It has to be one after the other. Stacking, hello. How are you doing today? Okay, so I was running into a lot of trouble trying to figure out how to do this. It's a one after the other type situation, which makes me think that I want something to go just in order. Like I first do like the motorized steps. Like it's okay. The first thing you do, which makes me think I want maybe a small one. Where I could say, okay, I want to start with sleep. Oh, it's not sleep X, so we're gonna move X0 to ACC. We're gonna test if equal ACC is -999. If that's true, I want to jump to start again or jump to end. Let's jump to start. No, end. I like end. We're just gonna sleep 1 and then move on to the next thing. Okay, so at this point in time, we know that it's not that, so I need to take these 2 numbers and send them to their appropriate spots, wherever that's gonna be. Charm just made a pretty cool tool that I thought you would like. It generates them terminal pictures that you see all the tutorial sites. Ooh, that'd be pretty cool. Oh, that's a great charm bracelet freeze. Okay, let me copy. Check out charm bracelet for terminal photos. All right, added to the backlog. let's say I do this, then I can have essentially moving out each of these. So let's say I do, see, motor is the first one that's up here, so maybe this one should be motor. So move x0 to x3, move x0 to tool clean is the second one, so that would be x2. Move x0 to x1, and then we're done, and then we move back into sleeping mode. So sleep, and then do that. Oh, but you know what? This is the exact same problem again. I need to sleep for the appropriate amount of time before doing it, right? So let me think here. So if I have a 2, it's not just sleep 2, right? It's it's unknown, right? Because I need to move to wherever I'm going. Yeah, because like when I go to here, it's like actually 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I think what I need to do is send them all to the next thing. And if I send it as a packet, a data packet, I can take you, for example, to give ourselves some room. Maybe I can even come out here. Oh, nope, that's not tab. So I can do something like that. And this would be our first one. I'm losing some space over there, but that might not be a problem. Charm has been knocking out of the park with these tools lately. Oh, interesting. While I'm in that repo, maybe I'll take a look at some of the other tools. I don't think that's a user that I've ever followed. Okay, so if I move, I just want to move these out, right? So you're moving to X3, you move to X3, and you move to X3, just all together. Just move them all, and then we're good to go. And now I want to sleep X on X0. But when I get something, we need to start processing it, like right away. So the first one that we get is going to be moving, right? Oh, you know what? Another thing that I just realized that I could be doing instead? We could still do the controller thing where I send it the one thing and then I have to wait for it to come back and send me something back before I move on. That could actually work a lot better than me having to like handle both things. Ooh, okay. So hold on, let's go back here and do this again. I think I might need a bigger one. Okay, so let's move X0 to ACC, let's say. Let's test if equal. ACC is -999. If it is, we're gonna jump to end. For end, we're just gonna sleep 1. If we don't have this though, I probably need to send these all on X's. So something like that. All right, so we're gonna move, oh, it moved it. Okay, so the first one is actually gonna be an ACC, isn't it? So move ACC to X3. And then I wanna sleep X3 to like wait until I get something back. When I get that back, I have to do something with it. So we're gonna move X3 to null. And then we're going to move, at this point, now we're back onto X0 to X2. Sleep X, X2. Okay, we got that. And then move X0 to X1. X1. Why did I move that? Okay, that's X2. And then we're good to go. So now we know that all of them have been completed doing their jobs. Then we just sleep 1 and then we move on to the next thing. Okay, so that being said, now if I do our motor thing, can't go here, I have to go at least 1 up here. What do I need for the motor? I need to store I need to remember where we are right now, which can be in data. Oh no, it can be an accumulator. So okay, first off, we're gonna sleep on X0, and as soon as we get this, I need to probably move this into data. If we are greater, okay, so if dat is equal to ACC, we don't have to do anything, we're already there. If, however, we are greater than, okay, so test greater than that ACC. So if we're greater than that, I want to pulse positive. So let's see, we're gonna add 1 to ACC. And then I want to send a 100 and then back to 50. So move 100 to P1. Sleep 1, move 50 to P1. Okay, and then I need to do this all over again. Oh, but then this could be like a move label. And so I can now do test less than that ACC. Okay, so if data is less than that, I want to move left. So that's pulse 0. So sub 1. Move 0 to P1, sleep 1, move 50 to P1. This move 50 to P1 I do no matter what, and so I could actually just have this jump to end move. Oh, I don't have enough. Okay. End move. Okay, so end move, we move 50 to P1, and then I want to jump back to this. So test not equal. Ooh, yeah. I think there's a test not equal, right? Test not equal. Dat and ACC. Oh, there is no dot. Test equal to dat and ACC. If you're not equal, then jump to move again. Otherwise, we go back to sleepbacks. Oh, but then I don't send anything back on X0, which is the problem. Like, I think this should move us. Like, if I run this, ooh, it didn't even move us right. Okay, jump to end move. Move 50 to P1. Oh, I need to sleep. I need to sleep 1. Can I get away with not moving this? Can I just say this and I just want to test greater than X0? ACC. Add 1, move that, sleep 1, jump to end move. Why am I jumping end move here? I think then okay, test less than, sleep 1, then we have end move where I move 50, okay, back. Test Fiat, jump back to move. I need to sleep 1, jump to move. And so if you get to here, then I want to move like 0 to X0. That went a little bit too much. I think I want to oh, I need to start at 50. That's our other problem. Okay, well that's okay, so this isn't working. It needs to like start right away too. Like I can't sleep wait. Like I can't take one tick to like throw a bunch of stuff into memory. I don't think I can throw a bunch of stuff into memory all at one time. Can I? Like, let's say we start with move 50 to P1 because that's an initialization that we need. But then let's also move 0 to X3 to reset where we're going to start writing in. And let me write into X2, so that let's just say move 1 to X2. Oh, I just saw that an ad is starting in 40 seconds or so on Twitch. Yesterday we reset the ads to 1.5 minutes every 30 minutes on request. So let me know how this works for all of you. It should be half the amount. Well, it's the same number of ads, but it's spread out twice in an hour. Okay, so move 1 to X2, move 2 to X2, move 3 to X2. It's like all in one frame, right? And then I'll just like sleep. Okay, and this is just gonna be doing this constantly. So every frame we're gonna add this in. I guess then I'll sleep X, X0. And I just don't do anything after that. That's fine. Ooh, okay, so that does work. All in one frame, I throw that in there. So we're still on here, and now I have these instructions here. So what I could do is have a chip that just puts the move instructions of what I want to do, like the powers. Ooh, let's try that. So I start with 50 out, just to make sure that we're going out. And then maybe you're not actually sending out. Maybe all you're doing is just controlling this. I think I need one more room here so I can do some funny stuff with that. And then maybe have something else control this chip. I don't know. Okay, so we're gonna sleep X on X0 and move X0 to DAT, just so we have it there. We're also going to, I'm not gonna have that, so we have another room. I want to move 0 to X3 to initialize the memory. And then our ACC is starting at 0, that's fine. Then we test, okay, so test greater than, if DAT is greater than ACC, and I want to, we want to move 100, so move 100 to X2, move 50 to x2. Storing what we're going to be doing. Okay, then test less than that ACC. Move 0 to x2. Move 50 to x2. Okay, so that's both if we're moving left or moving right. I also need to add one, so add one, sub 1. And then I do need to repeat this until we're no longer equal. So test equal that ACC. If you're not equal, jump to move again, which is here. Otherwise, we're going back to here, and there's nothing for us to do. Oh, but I need to send a response back out. So then we just move like 0 or 100, it doesn't really matter, to x0. And then we go out here. Okay, so if I do that, this should now be filled with the instructions for this, which we start at 0, so we should see, I should see 150, and that brings us to 1. 150, and that brings us to 2. Okay. $150, $150. Okay, excellent. And then obviously we're waiting for this to report back. Okay. Actually, oh, it's waiting on x2. It got x3 stuff. Okay, so I am a little bit concerned that this is moving back here. You know what? This doesn't move back. This has to move back. Oh. Yeah. This is just gonna go like that, and then you're gonna have to send something back. Which I don't know how that's gonna work. I could also use the memory to do all the instructions. But I don't think that's a good idea either. Okay, so given that, I think maybe actually this down here might be better. Nope, because I need to read it. I was thinking maybe I could do something like this, where I have like you there, or maybe even you like this, but that's close. That's not going to work with this. I don't have a room right there. I don't want to take up room there. If I just put this here, I don't have room to get this this trace over into there. I have to go down one? That doesn't seem... I'm using a lot of space just for the motor. I want to do D1 like that, and then U can be like that. And then use U. Ooh, so I don't know when to go. That's the other problem. Is like I need to send a message out here to then go, which means this won't have the correct number of exports. It's the really is the electrical engineering part. I think that gets me. It's the space. It's like, just let me have one more line. Let me have like 5 more lines. I don't know how ROM would help. This entire thing of like figuring out where to go and put this in here is a lot of space on a chip. Now I do have this move. Okay, so what do we have twice in here that we can repeat? Or that we can like combine into one? This move 50. And that move 50. So what if I just have this as a move 50 x2? Oh, now we have that problem. Okay, yeah, so that's an issue too. Okay, what if we don't move you into dat? So just move 0 to x3. To initialize this. We do our test greater than, move 100. I don't think I have anything that lets me move. Like I could try something here where it's like 50 0 100 0 or something like that, and then I'm just moving the index of what to do. Because we could say, okay, what if it's like 150, 0, 50. And then I pass it the index of where I want to go to. I read it twice and send that out. I don't know if that will help me either. Move 50. Okay, so here's where there's if I were to set where we want to go, I'm going to lose it with the data though. Oh no, because I'm not using data right now. So imagine I move, it's greater than, so I'm moving forward, so move 0 to that. No, I move 0 to this. Move 0 to x3. I add 1, we then test, you're going to move 0, you're going to move, so let's see, 0, 1, 2 to x3, sub 1, I don't have to do this move, now I have to do the actual move. So then we're going to, okay, so we're going to 50 to P1. I want to move X2 to P1, sleep 1, move X2 to P1. If you're equal, okay, so if you're equal, now jump to move. I'm not sending anything back. That's the only problem. This should move it, but it's gonna deadlock. Yeah, it's now waiting on you sending something back. No. Because I never did anything with it. That's the problem. I do need to move it into data or something. What if we start this with 50? No, because we need to start with 50. No matter what. Okay. Okay, I don't see a way of using this either without using too much space. So I don't think that's helping me. I can't use this chip on the motor. This definitely is going to come in handy on the tool clean and tool feed though, because we're going 0s to 100s. I think the biggest thing that hurts is the 50, the starting with the 50. So let's reset you a bit. If I reverse you, I can't put you like that. I can't throw you there. What if I did reverse and then we went like up around here and then back? Okay, so we do the same thing. We're gonna move X2 to ACC. Check to see if it's equal to -999. If it is, jump to end because we're done. Otherwise, we want to start working on this net again, right? So can I just do the P1 here, which means, okay, you need to 50 to P1. We start with that 0 because we start at position 0. That's okay. I want to, for this first one that's in DAT now. No, let's not move it to ACC. Let's move you to DAT. Do I have enough room here for a chip? I kind of do. What if I do this? Continue with that. Key one out here, and an X to you. Okay, could I do something like this? We're gonna sleep X on X0, move X0 to ACC, and then we're gonna initialize. If I say move right, that would be like a 1, and then a -1 for move left. And so all you care about is just moving. So test greater than ACC 0. So if you're greater than that, we're gonna move 100 to P1, test less than ACC 0. Move 0 to P1, sleep 1. Oh, and I don't even have to sleep 1 because this sleeps X. Maybe I should sleep 1, I don't know. And so that moves 1 in that direction. Okay, so if I do that, test greater than that to ACC. So if you're greater than, I want to move 1 to X3. I wonder if I need to sleep 1 at this point in time. I think I do sleep 1. So then I'm sleeping 1 here. I don't need to sleep 1 here. Ooh, I don't sleep here. I'm gonna sleep after. So test. I do have to. Okay, so hold on. It's greater than, move that, add 1. That's less than, that ACC. Move -1 to x3 sub 1. I sleep 1 because we reached the end, and then I want to test equal that and ACC. If you're not equal, jump to move, which will be right here. Otherwise, I do have to I think I do have to sleep. No, we've already slept. So then we're going to move the next two things out. So then I put you over here, let's say. Which I can't because I can't move both. I can't then move x2 to x1 and then move x2 to x1 again. Oh, but I don't need this, so I can. Okay, so if I just do this, this won't delay on. This won't delay on here. This will wait. This should move us, maybe. Part not sleeping, blocked on read. Wait. So x2 doesn't constantly send this out. I need to sleep. Oh, that's transaction. Well, that didn't work. I flatlined. So what happened? So... Okay, so we got -999, so we jump, sleep 1, test equal, okay, so dat, oh no. Then I jump to move, and I start trying to move, because -999. Oh, that's too bad. Okay, so... The 50 is working. That initialization works, but my logic for determining of jumping back to the move is not working, definitely, because I need to sleep 1 no matter what. I need to sleep 1 regardless if we're moving stuff or not. Like, that needs to happen no matter what. It's almost like I can't put this above the sleep 1. Yeah, okay. Err. All right, what are other things we can think of? What if I combine... Oh, it's been another half hour, so another ad break in 50 seconds or so. What if I combine those things into a single number because it's 222, so I can just do 222. That would be fine. And then I send that out. That would be like putting another one of these here and doing something like that. So if we move x2 to ACC, test if equal ACC to -999. If that's equal, I want to jump to end. We're just gonna sleep one and then it moves on. If we're not ending, I want to move, okay, so you're an ACC. What if I don't move you into the ACC? What if we first check to see if you're greater than 999? No. I think this will work. I can... How do I do this? Okay, we can set the digit of ACC specified by the first operand to the value of the second operand. Okay, so DST 07. So the 0 sets that to 7. Okay, so 0, 1, 2. So then I do DST 0, so the far right one, to be oh, interesting. Okay, so this is going to be 2 if we get here. So really, I want this to be 1. X2 DST 2 X2. So that now sets, I have a 3-digit number, and then I send that to over here. So then I move ACC to X0, and then we sleep. And then we do this all over again. So out of curiosity, if I sleep X on X2, we're gonna move For isolating the values, store the result in the ACC register, which kind of sucks. And the other one is oh, it's all ACC no matter what. So if I want to isolate out, yeah, okay, so I move x2 to ACC. And we have an immediate problem here. Because my I guess we don't have a problem yet, but we're about to have a problem because, okay, I have ACC. I have the number, so in this case, it's gonna be 222. I want to store I want to separate out and get that first 2 out. If I do that, I lose. I then have to have a completely separate move system like this that stores like where we're going. Which I don't think I can do with the ACC. Oh, sorry, with a small one like this. I wonder if there's like some math tricks I can do. It feels like for some of these, if there's like, oh, if you think of like oh, I subtract the current location from our destination and that tells me which directions I want to move. I mean, is that always true? It's like if I take 2, subtract from 0, that's -2, that's wrong. If I take 0 and subtract from 2, that becomes +2. Wait, is that right? No, 2 minus 0 would be 2. If the arm was over here and I had position 0, it'd be 0 minus 2, -2. Okay, could I do something like this? I move you to ACC. I need to move you to ACC and DAT, right? Because I lose it. So I have to also move ACC to DAT. I want to get digit 0, and that will be a 2. And I want to move that, so move ACC to X3. I want to SLX X3 to see when you're done. When you're done, I don't care what you send back. I then want to take the other 2 numbers that are in DAT and move them out to here. So then we're going to move DAT to X1. That's not too bad, space-wise. Okay. Now for you, we wait on X0, we move X0 to ACC, and this tells us what we're gonna move. So if it's greater than 0, I have to move 100 or less. So I have to test to see if it's greater than 0 or less than 0, right? For whichever one it is. It's just the count. So we're gonna have our move label, and we're gonna have to test greater than AC. If ACC is greater than 0, move 100 to P1. Ooh, okay. If it's greater than 0, move that. Test less than ACC 0. Move 0 to P1. And then no matter what, we want to sleep 1, move 50 to P1. I have to move that 50 to P1 and then test to see if we're done and move back to move. I need the bigger one. I wonder. So I do need a little bit of room. I'm blocking transaction, but that's okay. You come in here like that. So you're X2, that's fine. And then you move to this X0, let's say. And then, okay, so move X2 to ACC. We do this entire thing. I only need one thing over here. What if I put you like this? Then it can go like that, and this goes out here. And you could sit up like this. We can do you. Okay, let's fix this up. So we're gonna move X3 now. ACC, test that that's equal to that, jump to end. Set that digit to X3, that digit X3, and then move everything to X0, and then sleep 1. Okay, you are X2, so sleep X on X2, move that to ACC, move ACC. Oh, we don't have a DAT. That's our problem. That's why this one needs to be a big one. Because I need a DAT. Or I need a memory, which is like, that's not much space I'm saving. Have to do something like that. And then you can come out like that. Okay, so wait, I can save a little bit of space. If I do that. Oh, no. I keep on pressing escape when I mean press tab. We can go that. And then, I mean, it's not, we're losing a little bit of space, but maybe a little bit less. Okay, so you're the same. You're waiting X2 to ACC, move ACC to DAT, isolate the digit, move ACC to X1, wait on X1, move X1 to null, and then move what we have DAT on to X0. You do our move now, which is going to be the same thing, right? So sleep X on this, move that to ACC. I didn't sub it. Oh, because I need to keep the current actual location. I can't just sub that constantly, so I don't think I could do that other thing. Okay, so I wait for you to come out. What if... I wonder if I don't want this initialization there. Okay, SLX 0, move 0 to ACC. So get that into our ACC. That is the okay, that's the position. So actually I want to move this into data. Okay, test greater than if dat is greater than. Dat is greater than ACC, I want to move 100 out. Otherwise, if we're less than ACC, move 0 out. Okay, so we do those two things. I sleep 1. I have move 50 out. We have to sleep 1. And then we have to test equal to dat and ACC. If we're not equal, jump to move. If we are equal, do I sleep immediately? I move that extra 50. I think we're good. So I think now I just move 100 back to X0, and then that goes back to sleep X, and that waits until this is done, and then moves you out there. Okay, does this work? Uh-oh. Why did I continue running this? Like, everything was fine. Oh, I'm not adding or subtracting. That's why I have so much space. I think I only have one more line, which means that this is not going to work. Because, okay, if we're moving up, I also then need to add 1. And now I can't sub 1. And oh, we're back. Okay, so I'm back where we started again, which is this entire, like I'm within a couple lines doing it this way, but I'm having trouble thinking of a way to do this in a different way. Stacking, if you're there, out of curiosity, how close is this solution, or am I just completely off track on this type of thing and I'm just like continuing to circle around the wrong direction? I wonder if I could do the math thing in between these two stages. So like, let's say we move you all out here. I wonder if I could do this with a smaller one. Move this out x1 instead. And then what are you going to be doing? I think I need data too for this. I need the state or the data. So you probably have to be big. So if I do that there, so wait on x1. I'm gonna move this back out x1 again. Just let me know we're done. You're gonna have to be that. Okay, so sleep. You need to move out one more. You're gonna move this out. Okay, so sleep, that, get that. Move ACC to X3 on this one. And then move that on X1 out, and then X2 is where we're coming in. Okay. Now if I do this and we figure out how many to move, which direction to move, so we'll have so we wait for X1, we move X1 to dat. And we now know what position we want to go to, and we know our current position. I wonder now if I can combine the two here, where then I say test greater than that ACC. Okay, so if that is greater than ACC, I want to move one. So we just add one. Move one to X3, sleep one. No, sleep two for every move. Test less than that ACC. Sub one, move negative one to X3. Sleep two. Those sleep twos can be combined, I believe. Okay, so I sleep two. And then I want to test equal dat ACC. If yard, jump to move again. Otherwise, we're at the end. We've already slept. So I want to move one to X1 to say we're done. And then you change. All your job is to move us. So we have our move 50 out to start with. We wait on X1. We're going to move X1 to ACC. We're going to test if greater than. So I'm only going to send 1 and 0. Okay. So I wonder if I'm moving, I want to move 100 and 0 out. So then you are just, I don't have to test at all. We just move it, right? So we're just going to move ACC to P1. Sleep 1, move 50 to P1, sleep 1, and then I send, I don't have to send anything back. We're just good to go, and we reset. So this just moves. So if I do that, part not sleeping, moving 1 to X1. Well, we're not done yet. Why did I move 1 to X1? Okay, hold on. What happened here? Okay, so we have 2 and 1 going in. I sleep 2. Okay, so we're here now. Test equal dat ACC. Oh, you should be at do that. Okay, cool. So that works there. Also, I shouldn't be sending 1. I should be moving dat out. So that's, yeah, you now have 222 in here. No, I got confused. I do just move 1 out. It doesn't matter. I move 1 to X1 to show, hey, we're done. So you are. Okay, sleep X on that. Move U to ACC. Move ACC to DAT. Okay, copy it. Isolate 0. Move ACC to X3. Sleep X on X3. Move X3 to null because I don't care about it. Move DAT to X1. So then your job over here. Cool. Okay, so the movements is the motor is working as expected now. Well, that's good. And we have almost half the a little bit less than half the board to work with for the other two. So I hope they're going to be simpler. Otherwise, we're going to run out of space. And that would suck a lot, but we're farther than we were last time, which is we couldn't get the motor to work. So at this point in time here, we have I want to work on tool clean, right? So we're going to get 2, 2, 2. Okay, so I can't move you to DAT. I have to move you to ACC. Because now I can isolate, oh, and then save it to DAT. So move ACC to DAT. I want to isolate the digit 1. That gets me the number of pulses that we're going to send to here. And then I just want to do it, right? I want to generate a pulse. So that's going to have to be on this. Oh, you're an X. I'll do something like that. But I can't, oh, I can't gen on a P. Do I really want this then? Maybe I don't. Maybe I just want to do something like this. And then I don't have to go through the middle of the board. I can go all the way around that side of it. Like that. Okay, so I want to generate a pulse to the tool clean of, what is it? Generate on P0 a pulse of on for whatever's on the ACC, and then off for 0. And then I probably want to send a message to the next thing. But if I don't worry about that, ooh, wire. Oh, you're off because of this thing here. Okay. Oh. No, never mind. This is all part of this one pulse. Okay. Oh, because you moved 0. That's off when we move 0. I'm off by 2 here. Because I think I sleep 2 regardless. That's why I'm off 2. If I'm already starting on... So, okay, it tells me to move to position 0, and I know I'm on position 0. So if right here, if I test equal dat and ACC, jump to end, ooh, I'm doing that test equal here. I should move this around. So I can maybe move. The first thing we do is test equal to dat and ACC. If we are, jump to end. Otherwise, we continue on to going through this, which includes the sleep 2. You just always jump to move again. And you are end. Yes, okay, so that works now. All right, so now we have tool clean and radio RX working, or sorry, and motor working. Okay. So we lost a little bit more space, but we have 1 tool left and all this space to deal with it. Let's, oh, I also need to make sure that we're done at the end of this, right? So we know, okay, so I generated this and then we're gonna send a message out to the next thing, which is gonna be move dat to, let's say, X1. And then we go back to sleeping. So if I wait on X0, move X0, so I don't need to do the dat thing anymore because we could just go straight to ACC because we're done with this. So I want to move X0 to ACC, get 2. I then want to generate a pulse on P0. So gen a pulse on P1 for ACC, and then wait 0 after it. And then I don't have to move anywhere. We're good, right? I think we got it. Oh, that was a tough one. I wasn't 20. I had the most. I was the most expensive, and I used the most power, and I had the most lines. Okay, I wish that I could see what these other ones were, like what the solutions were at this point in time. But all right. Okay, from Woo. I've received word that Mr. Sun was happy with the result of our work here. Clearly it's part of a much larger project, but nobody I speak to will say anything more. Oh, okay, interesting. I am, let's see, it's been almost 2 hours. I'm gonna go ahead and take a really quick break, just go use the restroom, and then I will be right back to continue with this. So probably not a 3-minute break, probably a little bit less. So I will be right back. All right, I'm back. Let's see. I think we got another junk mail next. Incredible opportunity, land rich in rare earths, from Rare Earth Advisors. We are contacting you about an incredible, once-in-a-lifetime opportunity to own land rich in rare earth metals in the western region of China. What are rare earths? Rare earth metals power the world's electronics, phones, engines, motors. It's fair to say the world would not run without them. But the world's supply of rare earth metals is drying up. Mining companies can't refine them fast enough to meet demand, and now the mining firms are looking to expand. Now is the time to own this land before the mining firms find it. Yeah. Interesting. Okay. So it's from Miami selling land in China. Interesting. No, thank you. Okay. Remote kill switch. I would like to have a remote kill switch for autonomous systems, robots. This is in case of failure of the autonomous system, of course. Such a switch would not be needed if we always design the system correctly. We should make this. I will create the transmitter and you will create the receiver. Okay. Okay, so radio RX is a non-blocking X-bus input connected to a radio receiver. Power 0, Power 1, and Power 2 are simple outputs connected to a high-power switches that control industrial equipment. When a data packet is received over the radio, read it and execute the corresponding command in the following table. Okay, so if we have... Oh, data packet, so we get all... Sometimes we get multiple, and sometimes we get nothing. Interesting. Okay, so if we get -1, keep alive, do nothing. If we get 0, power off, read another value, and turn off that output. 1, power on, read another value, and turn on that output. Oh, okay. So we get 1, 1, so turn on power 1. Okay. I don't have to initialize any of the values. Okay, so we're going to move X 0 to ACC. Okay, so first we're going to test if... Oh, if you're less than 0, we do nothing. Okay, so test if... test less than... ACC is 0. If you're less than 0, jump to end. End is sleep 1. Okay. Well, we've handled this first case. So, yay, we got the first few things. Okay, great. Next one. If it's not less than 1, we are going to read one more value and then either turn on or turn off. Okay, so read one more value. So move X0 to dat. So now I have the second value. If the first value is a 1, I want to turn on the second thing. Okay, turn on the other thing. Okay, so test equal to, let's say, okay, so if it's 0, so if ACC is 0, then I want to turn on whatever the port is, right? If I use something like this, okay, so you're going to tell me which one to do, which is going to be the 0s, 10s, and 100s. We'll turn it on for fully. I think that's how that works. So if I just do something like that. So if you're 1, switch on power 1. And I believe that's going to be in 0, so move 10 out. Oh, and we can have multiple things coming on at the same time, and I have to remember that. That's going to be... Oh, that's going to be a thing, too. So maybe... Because who knows? I already cost the company a lot of money. This will be fine. What if I use multiple chips? Like 1 chip per. So we're starting with nothing, which is fine. And I just want to then send you a message, turn on or turn off. And I have 3 things here. So I could do that. And I don't even have to worry about telling you to turn on or off. I just can tell you, let's see, I read one more. So now I have if I'm turning on or off and which one to do it on, right? So test equal dat to 0, and I want to move ACC to x1. Test equal to dat to 1. Move ACC to x2. I don't think I have to have like the test equal, like if it's this one otherwise, but I think this will be more consistent. Do we need to wait until you're done? No, because you just do your thing and I don't care about that anymore. I think we're just done. So here, I move you to ACC, and then we say, oh, we just check to see. Okay, so if you're a 1, I turn you on. If you're a 0, I turn you off. So test equal ACC. If you're a 1, I move 100 to P1. Otherwise, I move a 0 to P1. And I don't even think I need to sleep. Like, that's pretty much what this is. And I think I can just copy this in here for all of these. That worked for power 1, and it kind of worked for power 2. Oh, because they all got turned off at the same time. Wait, why does that get turned off here? Why did they all become 0? Turn off all power outputs when 5 or more time units have elapsed without receiving a data packet. Oh, okay, so that's the kill switch there. Oh, well. Well, that's fun. That's the one that makes it hard. I don't think I have enough room, because like every time that we do this, every time I set this out, I have to reset it, right? So like, let's say I sleep 1, I add 1. If I test I won't have enough room to move everything out again. But I am sending ACC out. Oh, but I want to send it to everything. What if I instead do the same thing here, where you have some logic there, and we use you? Let's see, I can... No, I can't use this side. I have to use this side. Where you'd be coming out like that. Is that turning it on or off? I don't think I even need these anymore, do I? Because these are just 100 or 0. So I don't need you. So then what I need to do is calculate the number I'm sending here of which ports I'm activating or not. And I need to use ACC to determine how that I've captured these. Haven't I? Yeah. I wonder if I want to use like another chip to like, okay, just count how long it's been since then. Because I could use another chip here. I could do something like this. I could do something like that. And then every single time I send something, I also just send you to you, and you're our power off in case we don't receive anything. Because if I just move P0 to ACC, I need that. Can I test less than P0, 0? So if you're less than 0, add 1. Otherwise, reset this. So this is move 0 to ACC. And then we want to test if greater than ACC 4. If you're greater than 4, we're going to move 0 to X1. Turn them all off. Sleep 1. And so that becomes our turn off all the power. Okay, so now you need to be rewritten a little bit. So we're going to start with move X0 to... Do I send you to AC? Let's send you ACC first right now. And I want to test... I also want to test you out right away. So we're going to send you out of here. So move ACC to P1 right away so we don't forget that. Now, if you're less than 0, I do nothing at all. So test less than ACC and 0. Jump to end. Okay. You're 0 or 1. So we know that. I need to now calculate which one we're doing. If and I have to calculate which position to set it in too. Do I want to use, I think I want to use dat here. Okay, in dat, I have the command to use. I need to read the other thing and then set which one of these we're going to send out. But I need to keep track of which ones we've done. So we start with ACC 0. You send me this. Okay, so can I... The DST? I think it's like digit set for ACC. So I want to set... from X0. Just turn that on, right? Like that just becomes a 1. It doesn't really matter what it is. And then I move ACC to X2. And then we sleep 1 and do it all over again. Does this work? Well, not exactly. It turned on those appropriately. You turned on and then you did not turn off. Okay, so I received a 0 and 2. Okay, turning on is working. Turning off doesn't work. Oh, because I'm always turning this on. That's the problem. I set this to dat. The kill didn't work. The kill switch didn't work. Okay. Why not? Okay, so we're at here. All of them are at 100. We've 0. Oh, you're never adding. This should have been adding multiple times up here. It's not been. So test less than P0 0, what? Move dat to P1. Oh. So that's not working. I think I need a bigger one for this. Okay, so let's move you to dat. We're going to test less than. If dat is less than 0, we're going to add 1. Otherwise, we're going to reset you to ACC. Then we're going to test greater than ACC 4. Move 0 to X2. Sleepwalk. Okay, let's see if that works. This ACC is never going up. Okay, what's going on with this? Move XOR to dat. So yeah, you're -1 here. Why aren't you -1? Maybe I don't want to use, maybe I do want to use one of these ports. Okay, so move dat to X3. Move X1 to dat, and then we go from there. Interesting. Okay, much better. I turned off power 1 because, oh, you got... Okay, so I think my math is wrong. I'm pretty sure I shut it off here. Oh, okay. So if it's less than that, I add 1. If it's less than -1, really. Ooh, and now I'm off by 1 here. Okay, let's try back to 4 again. Why did you 2 turn on? Okay, so what's going on? We are going to receive a 1 and a 2. So we step through. I send in a 1 to here. It has not been 13. That's interesting. Why are you ACC 13? Okay, so test less than 0, dat 0, I don't do anything. Okay, so don't to jump to end. DST. Okay, so I want to set x0 dat. So I want to set the ones, right? Oh, because you're reset. Because 1, 2, 3, 4, 5. Oh, whenever you reset here, I need to let you know to reset this. It's almost like I need a response back to here. So before I sleep 1, we're gonna move. This moves, okay, so 0x2. Okay, so also this, we're gonna move 1 to x2 to say we shut it off. Otherwise, we're gonna move 0 to x2, x1, x0. And then we're gonna sleep 1. So you're gonna get this out. So before we sleep here, we need to check. Okay, so we want to move P1 to okay, so we're done. I don't care about dat anymore. So move P1 to dat, test equal dat, and okay, so if you're 1, I want to move 0 to ACC, reset you. Otherwise, we do nothing and we sleep. Oh, but because I can't do that, I can jump you though. Hold on. We'll do P0. All right, did we get it? Oh, and we failed. Okay, we failed over here. What happened? This feels like an off by 1 error of some kind. Okay, so at this point, our AC is 11 because we've turned on 0 and 1, and then 2 is off. That makes sense. We are about to receive 1 and 2. Why do you turn off then? Because you got shut off. You got shut off because it's 5. I think I'm off by 1 error here, so right. Now you have a 111. Okay, so I need to, when we shut off, when are you doing that thing? Okay, we go to end. So here, I need to check here. So 1, 2, 3, 4. This is the 5th one. So we're about to get 5 here. So we move dat to x3. You do your entire thing. I should probably wait. What if we wait for you to come back? So what if I, instead of this, because this is an, what if I just send back out here? What if we don't use P0 for this? What if I just use this? So we say, okay, move dat to x3. And then I want to sleep on x3. When we get there, I want to test to see okay, so if x3 is 1, then move 0 to ACC at this point in time. Move x3 to null, and then we continue on our way. And so then if you're greater than that, I just want to send 1 to x1. Otherwise, I don't care. Move dat to x3. Wait, so that moved the dat over here. Shouldn't this work? Because we're not sleeping. Okay, so the first one worked. We get that negative 999. We add 1. You're sleeping, waiting for that. Oh, I do need to send this out. Okay, never mind. Oh, do I not need to do that because I did something? Wait, so test equal to s x3. Wait, did I do that for everyone at once? Plus, move x3 to null. Did I miss the plus? I don't think I cut you off. Okay. What if I don't have this send out to here? We have only one thing send out. Like that. And this is really just going to keep track of our accumulation, right? So we move x1 to dat. I test, okay, so if you're less than -1, so we haven't received a, so really if, okay, so if test equal, dat is -999, I add 1. Otherwise, we reset ACC. I then check to see, okay, are you greater than 4? If you're greater than 4, I want to move cut to x1. Otherwise, I move we're okay to x1. And then we sleep 1. And then we're good to go. So you move you to dat, move dat to x3, and then I'm immediately going to get something back. So then I don't have to sleep on you. I just need to test to see, okay, so check test if equal x3 to 0. If you're 0, want to move 0 to ACC. And that resets it. I think I also have to move x3 to null because I don't care anymore. Okay, so test equal, I don't need that anymore. Okay, so test equal dat to 0. Oh, test less than. Okay, so as long as if you're less than dat 0, we jump to the end. Otherwise, we set the appropriate thing and then we move that out. Oh, and we never move this out. So if we're done here, I probably want to move maybe I don't move ACC to x2 here. I move ACC to x2 here. Immediate sleeping. Do I keep on forgetting if I need that move here. Stuck on the breakpoint. Yes, we got it. Excellent. That was so much faster than the last one. Sweet. Can't be too careful when you make robots. Am I right or am I right? I am learning some more casual style English from Joe. You scared me for a second there, Jay. I mean, okay. I think it's fine. All right, next one. Smart Grid Control Router from Wu. I'm pleased to say we have been selected for another Sun Haoshan project, a simple data router for smart grids. Mr. Sun was never interested in civic infrastructure before to my knowledge, so I really wonder what he's planning. I may ask around. My uncle's had dinner with him once or twice. We can do it. Note, these XBus inputs are blocking, so we will need to connect all inputs so they can be read at once, simultaneously. Oh, there's a lot of inputs and outputs here. What? Meter in and meter out are XBus inputs and outputs that connect this node to a building's smart grid power meter. Lower in and lower out are XBus inputs and outputs that connect this node to a node with a lower ID number. Okay. Higher in and higher out are XBus inputs and outputs that connect this node to a node with a higher. Okay, so it's basically the router where it's like, hey, if it's ours, we do something with it. Otherwise, we're gonna pass it up or down. And it's almost like we're in a tree. Hopefully a binary search tree for something like this. The first value in a data packet is the ID number of the destination and indicates how the packet should be handled. Okay, so we get the local ID number of the node is stored in a secure identity chip that can be read as an XBus input. Okay, so this is our ID number. The second value in a data packet is the length of the rest of the data packet. Oh, fun. So no matter what is coming in, it's going to be the exact same thing, and either I forward it along. So meter in is coming into this meter directly, but it could be also receiving from a completely different grid. But it's going to be the exact same thing. So I need to sort of like combine them together into like, okay, so it'd almost be like a combination here. Wait, why did I do that? I want that. This combines into like another thing that actually is going to do work. Like that. You will probably get out of there. But then I need to retransmit the entire data packet out of these, which I might have to do something like this so that I can use that P there. Oh, but I don't have room here, so I have... Okay, I might be able to get away with the small one on the left. So if I do something like that, this gets then sent out to something else that deals with you. If I throw you in here, now I could do that. I mean, I have no idea if that's a good idea, but that's certainly a chip design we can do that like sends everything over. So I have to combine all of you into here, into like one thing, and then send that over. Can I do that with a small one? Am I, what, let's see. I'm not always receiving something. I'm receiving something on some, no, because like there's a lot of waiting on these. Oh, that's interesting. Sometimes I receive them on both of them at the same time. Yes, like meter out. Sorry, meter. Yeah, okay, so the ends come like this. Only one of them gets read at the same time. Ooh, okay. I can't use SLX. I don't think I can use one chip for these, can I? So this entire thing won't work. Let's reset. I think I have to use 3 chips. If I do something like this, I can now grab those in, like you. How to combine these together, I'm not sure. Like, do I need to just duplicate the logic across all of them? That kind of sucks. I doubt it, though. So let's take this case. Lower in. So we first get the address, and I need to check to see the address of this thing. Which... Can I do something... Okay. I wonder how crazy this could be. If I could, like, just say, hey, we're all talking to it. I'm curious now. So can I move X3 to ACC? And then it'll just sleep 100. Let's try the same thing. Sleeping for a long time, so I can just play this and see. Oh yeah, that grabbed it all. Okay. So that actually kind of works. So I can get our address here. which means I can SLX on X1. Move X1 to ACC. I want to test if equal. ACC and X3. I probably want to do greater than or less than, right? Can I test this multiple times? Okay, so test greater than X1, ACC X1? Okay, so if the ACC is greater than what we are, I want this to send out, right? So what if I do like 0, 1, 2? So then I move 0 to X2, and then I move the number of the following things. This would be telling it which one it's doing. Oh, I could set this to write into memory. I could set this to write into memory. The only negative is that nothing in here is I don't have enough. Yeah, if I use these ones instead of those ones. So if I do that instead, how will everything now properly connect to A0? That will be interesting. Oh, I could just do this. Oh, I can't do multiple jumpers. Okay. Can't go that far out. So I've lost this one now. I can't jump out there. Yeah, and then I lost this one here. I guess if I just don't be consistent, it works. So I have to remember which one is which. Okay, so as soon as I receive something, I move it into ACC. Oh, what if I move it into memory? What if all I do is just move it into memory? So we start at 0, which should be fine. So move X1 to ACC. What if I don't? Let's see. I do R's. The next one. No, okay. I could just test. Okay, so test greater than ACC. So if you're greater than. If you're greater than this, we're going higher out. So that would be move, so what? 0, 0, -1, 1. So move 1. To X2. Test less than ACC X1. Move -1 to X2. Test equal to ACC X1. Move 0. Oh, but now I can't move the rest of the things out. So that's that problem. Okay, so if I don't worry about this thing right away, I just move everything we got into memory. So sleep into you, and then we're just gonna move. It's always gonna be no, because this is the number of instructions, right? Because like 3 and then yeah. Okay, so we're always going to move the first one, right? So move X1 to X2. Move X1 to ACC. Move ACC to X2. And now I subtract, right? So we have a loop. Test greater than ACC is 0. If you're greater than 0, I want to I guess we can test the exit. Test equal to ACC 0. Jump to end. We're not, okay, so we're not equal to that, so I want to sub 1. and I want to move x1 to x2. And then I need to jump to loop again. So this will be start. Maybe that'll work and it will fill this up. So this only works on higher and everything else will ignore it. Ooh, okay. There. Okay, so we got... Oh, he's started with 0. Right, 0, because we are equal to it. 573, it's ours. Oh, I want to send it out. Well, that's unfortunate. However, everything else worked fine. Okay, what if I move, what if I don't test equal? What if I just move this over too? So... wait on x1. Move x1 to x2, so send this out. Oh, that was a, wait, that's a 0? Oh. Why did you move here? Higher in is the only one trying to communicate with you. And I'm still on start here. That just is literally how it starts. Cool. I need to reset you to be like starting at 0, right? So like, okay, so if I sleep on this, I have to immediately move a 0 to x3. Oh, I'm reading from here. That's the reason why. Okay, hold on. Much better. Okay, so I'm actually curious about this now. So if we go until the higher end hits it once. Bam. So we get 573. Okay, so move. Okay, so I move that to X. Yeah, so then this is not necessary at all with this. So that goes away because I'm not reading that at all. So then I need, we have 3 X's. That's gonna have to be you, which I don't have room for you, so I have to shift everybody over to the left. Now I do have room here. You need an X out there, an X out here, and then I need a... I don't have room for another X to pull in this thing, which that's going to be rough. I mean, I could throw you in here or like hide in between here too. I don't know when I'm going to receive these, do I? I want to say it's not always the same time frame. Yeah, sometimes I'm receiving them at the same exact time, so I don't think this is a good idea at all. Because I'm going to run out of space. And how does it know which one to receive? Still not recommended for these other parts. What is that? Oh. Wait, I gotta do logic gate programming? That's really cool. I guess another question is, am I making assumptions about the X bus gate? Because I keep on forgetting how it works. So if I have something like you, I don't think I can't sleep on it, but can I try to move on it? So test. Well, I can't move it. I could test it to see if it's greater than 0. So test greater than 0, like x00, 0. And if you are, like, jump to go, like I test greater than x10, 0, jump to equal, test greater than x20, 0, jump low. So no matter which of these I go, we'll just, I don't know, we'll add one, just so that I can see that this is happening. Yeah, part not sleeping, so it's blocked on that. So I do need to sleep on the port. I need to sleep on the port. But if I'm sleeping on this port when something else comes in, that's not good. So I do need a separate chip for each one, don't I? This won't work for me. Because I lose the number, don't I? So let's say I were to throw this on one here. P2, P1, or P0 will fire. Oh, why did I send those? I keep on doing this where I send it to each other. That's not what I want. Oh, interesting. I don't know why I'm not seeing this out. So Find 96 should send all of them. Yeah, that's just gonna launch. That's just gonna make them all go. So again, not what I want. I think it's gonna be something like this, where I have to have like some sleep on each one, and then the crossing is gonna be tough, right? Because if it's higher in going to higher out, that's easy. I can just go straight across. If it's higher in that goes to meter out or goes to lower out, I need to pass it to the appropriate spot. So essentially I need a router in here to forward on the appropriate things. Which I could see something like this doing. It's like a combination of a couple different one of these. This is interesting. But it's not recommended, so we're not going to look at it right now. I'm at that point again where it's like, okay, it's been 3 hours and like my brain is not working on it working anymore. Okay. Combined with the drop frames and how like the quality of this, I don't know how I don't know. I don't feel like it's a good idea to keep them going for too much longer. And I don't see a good solution here. If I grab, okay, so if I put something on all of these, the thing that's confusing to me is what happens in here. How do I send you to say go to a lower out? That's the question. It's really one thing, right? Like no matter what, I send to something like this. And if I combine the trace coming out, because only one can come out at the same time, right? So if I were to do something like this, I still need an X port for this. But I could use this for that, right? I could... go like that in, and now I have room for... I have room for that. Can I fit all the logic to do everything in here? I don't know. Oh, and I have P. I don't have to... Oh, no, I do. It's a good idea. Okay, never mind. I have to do it that way. Okay, so all of these would be exactly the same then. So you take in like X1s, like sleep on X1. And then I just want to move the first one out, so X1 to X2. Just blindly move that. Then I have to move X1 to ACC. Move ACC to X2. We have to do our loop. We have to sub 1. I don't think we're ever going to have one with 0 instructions, right? So sub 1, and then I move X1. Okay, so move X1 to X2. Test if equal to ACC 0. If you're not equal to that, then jump to loop. Otherwise, we're done, and we just go back around. And so if I take you out, and the only difference is you're X3 instead of X2. You're obviously going to have to wait for X1, so X1. When I get something, the first thing is going to be, I want to compare to get higher or lower, right? It's like to figure out where we're sending this. I'm only communicating through you, so I have to move X1 to DAT, let's say. Move DAT to P1. So we're going to move P1 to ACC. I want to test to see if you're equal. Okay, so test equal ACC to X0. If you're equal, we're going to move this is not going to work because it's a simple port. If I'm sleeping until waiting, this is not doing that. I think I need a conversion over here. Oh, but no matter what, it's gonna not work the way I want it to. I'm using a simple port because I don't have enough X's on here. If I tried to combine X's here, like one X to go out, can I rotate the chips? That'd be nice. I'd have to give it instructions for like moving up or down, which I already have coming from out of here. So hold on, let's. Oh, but I lose this X. I still lose that X, but I can do that where it's like these all come in together this way. Now I have access to this X. You're back to X2 again. I can do something like that. You can go straight out there, but I need to do something like that here. Basically manually creating my own one of these, but it keeps the numbers. I might need to use a big one. Which gives me a port mismatch. Unless, no, this will still be a port mismatch. If I put this down there, does that help? Yeah. Do I need you at all? Can I get rid of you? So if I can move you down here. Just go straight in here like that and get rid of you. Move you up here like that, and now I can't go out that way, I go out the other way. that would work. I just need to make sure I can do this all in one go here. And then I send you up there to go out either of these two. That's a lot of things that this one chip needs to do, though. I'm a little bit worried about that. All right, well, let's see if this works. I would be getting everything in on X0. So let's say I move that to data right away, and the first thing this is going to be is our address. So if I test greater than that, okay, so if data is greater than x1, we're going to hire out. So that going to x3. So then I want to move, let's say, hire out 1 to x3. I need to move the entire data packet out, and then I need to move the entire data packet out again to here. I can't use dynamic ports. That would be nice. If I could store like an X3 in DAT, I could then use that. Yeah, I don't see how this is going to work either. I think it's going to be running out of room. We can try it anyways. So if I move, we'll move one up there, and then I want to move the actual thing. So DAT to X3. Let's see. Move X0 to DAT, move X0 to ACC. So that's the number of things. I want to then move X0 to X3, sub 1, test greater than ACC 0, jump to, where am I jumping? Jump to loop, jump to high loop. In high loop, is here. So if we get to this point, it's coming out. Then I have to do lower to here. Okay, so no, meter out. I have to do higher meter out there. So if I do it the other way around, if we just figure out if we're lower loop and we just send you out, otherwise I just forward you all into there, will that work? So I have to move you into data. I have to check to see, okay, so no matter what, I still run into the problem where I have to check to see which one you are, higher, lower, or medium. Wait a second, I just had an idea. Let me reset. I can combine the cables for X buses. We found that out already, right? So I just do this, and now one thing reads this. So I don't really care what it is. So sleep X on X0, move X0 to that, let's say. I then compare that together. This is where I wonder if now I send this into memory. If I could send you into memory here, I'm running a little bit of room. But okay, so I just move. Maybe we start with what we are. So we move 0 to X3 to reset there. We're gonna move X1 to X2. Move X0 to ACC. Move X0 to X2. We're gonna have our loop. We're gonna sub 1. We test, okay, so we test first if we're equal to 0, so ACC 0. If we are, we jump to end, or maybe start, because jump to end. End, we're gonna have to send a message out. But therein lies the problem now. I have to send the okay, so I can't do this. I have to. Can't do you. We'll probably have to have something like this. And you'll be connected up there, maybe? And these will be connected to this, which is a problem. And it does make me wonder if this is where we need to start, is like assuming we need something like this. 3 of these out. Oh yeah. I feel like when I get stuck with these puzzles, I just keep on going back and forth in circles. And then we wait a week, I continue on with the fun day, and it's like, oh yeah, okay, let's just get it done. And it takes a little while, but hey, we get it done. It is taking us longer than TAS 100 to get each puzzle, though, I think. All right, yeah, so I think I'm in that not really solving this and just moving things around. So I think what we'll do, we've been almost streaming for about 3.5 hours. The stream has been up and down quality-wise, which is really terrible. So sorry about that for those of you who are watching. The recording should be fine though. So I will be, that should be okay. That should be our only saving grace here. And hopefully next week on Monday, everything will be good. Maybe I'll restart the router between then and now. I don't know what's going on with that. It's all on my side. It's not, as far as I can tell, it's not on a restream side, and it's not on YouTube's or Twitch's side. It sucks. But yeah, so I think we're gonna end it now because I'm not making any forward progress. So with that, I will be back on Monday to continue with the web development and getting the LMS ready for our Docker course and releasing that. And then besides that, I don't really have anything else to do, so I think we'll... Wait, I don't know what I said. I don't know why I said that. I hope that you all have a great rest of the day. That's what I meant to say. And have a great rest of your week. And I will see you next time, whenever that is. Bye.